Roundtable / inauguration here at IAAC Barcelona. I'm very happy that we have so many viewers joining us online, and we also have like a small crowd here physically present. I'm very happy to also welcome the speakers of this evening. First of all, we're in good company. We have The Guardian, who is putting out, and totally by coincidence, like this article just 4 days ago, and I swear I didn't read it before. But today will not be about communicating between trees and people, but, well, in a way, maybe. But it will be about pushing the boundaries of timber construction. And we're going to talk about innovation and experimentation using timber. So we all kind of became a bit wary of using Zoom and all of this, but also it has some good sides because it allows us to bring together a panel like this with people from mostly London, I have to say, maybe Birmingham, and there is also Geneva, but otherwise impossible to, on relatively short notice, assemble a panel like this. So I'm very happy that today we can welcome Kasper. He is the director and founder of AJG Architects in Copenhagen. And Kasper also has a background in education, having taught at several schools, doing research as well. Then we have Teresa Cheung, who is joining us from Geneva. She's the academic head of the Alice first year studio, which is a design build studio, where we just heard like 200 students are right now just finishing the exercise of this year, building one-to-one timber structures, of which we will later see what they look like, I hope. And we have Martin Self as well, who is the founder of Xylotek and director of Xylotek, which is focusing on advanced timber structures. And Martin is also the founder of the design and build program at design and make, sorry, at AA Hook Park in connected to the AA in London, and a lot of inspiring work that has come out of there, as you will see also later in our references. Then we have with us Steve Webb, who is founding director of Webb Yates Engineers, an engineering practice with offices in London, Birmingham, and Bristol. I like very much the quote on your website that it's about realizing intelligent and adventurous projects of all scales. So it's not so often, I think, that you would find the word adventurous in this kind of context, but it's great to see this spirit kind of on this level as well. Then we have Tom Westwood, who is a senior associate at Waugh Thistleton. I hope I pronounced this the right way. He's like a tongue breaker. And in his practice, he uses quite a bit of timber. So focusing on mass timber and cross-laminated timber in kind of large-scale projects, which we will see also in Tom's presentation. And then we have, last but not least, we have Manja van der Worp, my colleague here at IAAC for the 4th year now, doing the data-informed structures seminar, of which this is also kind of the conclusion this year. And because unfortunately, due to bad weather, we cannot show you live what we have built this year, but there will be a video and a presentation from the students at around 7:30. So what we're gonna do now is we're gonna start a round of quick presentations, like around 5 minutes from each of you after this introduction. And then we're gonna have our kind of moderated roundtable discussion until around 7:30, when the students will jump in, introduce the project, and then we can open up to the broader audience. And I would ask the people who are joining us through Facebook or Zoom to drop questions in the chat, and we will kind of assemble them. And after the presentation of the data-informed structures students, we will pass these questions on to the panel. So IAAC has quite a strong connection to wood. Oh, sorry, I actually forgot that Manja is obviously not only my colleague here at Timber, she's also the founder of YIP Engineers, which I think it stands for Yes, It's Possible. So another kind of adventurous and curious practice, and always a pleasure to have Manja and also to teach with you. So now, how is IAAC connected to Timber? Well, it turns out that actually we do own a forest. So there is like a property in the north of Barcelona, which is this fantastic campus of Valldaura, where there's a group of students living there and exploring self-sufficient buildings in a dedicated master, building prototypes like this one. But also, when you have a forest, and this is something that for sure Martin will recognize, when you start understanding the material from its origins, and scanning already the growing trees to impact the design of the finished structure, then this is something that becomes possible when you're so close to the origin of the material. And this is a project that Jean-Nicolas and Surush Garivani were doing at IAAC a few years ago in the Master of Robotics, scanning timber and doing this kind of wood sashimi. And the approach is to kind of tame the material, not by standardizing it into simple geometries, but to have an understanding of the material on a quite complex geometrical level, and with advanced construction or advanced fabrication methods, these geometries can be handled. In a different but related application, this also works with trash. So if you have this kind of leftover pieces, in this case from a carpentry, and the geometry that has to be first obtained and then can inform a design which is based on the contours of these offcuts. Again, possible through kind of these fabrication methods that can be adapted to the workpiece geometry quite easily using a robot. And then the almost, let's say, kind of normal way to use a robot just to do these dull, dumb, and dangerous tasks repetitive and boring, but with kind of slight variations in geometry that are difficult and for sure expensive to do with human workers. And this is actually the predecessor of the pavilion that is, let's not say pavilion, let's say the structure that we put on the rooftop this year. A greenhouse that consists of these standard profiles in a particular arrangement. And right now we have the follow-up project of this one on the way, which will be a greenhouse we're building in Sofia in the course of a European project. And last not least, from the seminar that Manja and myself are teaching, we are doing this kind of timber, let's say, almost as an educational tool to be able with first-year students to understand about fabrication, structure, but also assembly, logic, etc. Everything needed to actually physically build a structure like that. And this happened to be in Kathmandu, in Nepal. So yeah, that's it from my side. A little bit of shameless self-promotion, like there is a couple of master programs here at IAAC that actually I realized when I put this together that they all have timber in their logo. So there is the MAA, Master of Advanced Architecture. There's the MRAC, the Robotics and Construction Masters, in both of which I'm involved. And then there is the new online master, which is the Master of Mass Timber Design, and the Master of Advanced Ecological Buildings and Biocities. If you want to do that, you can live in Valldaura as a as like a student in the forest. Yeah, check out those programs on our website if you're interested. So that's it from, let's say, our history here with timber. IAAC is a young institution, but already there's quite a portfolio here with this material. And I'm curious to see what the panelists have to show and what angle you bring to this topic. So Kasper, if you're ready, I would like to start with you and your presentation.
Yes, thank you very much, Raimund. Can you all hear me?
Yeah, loud and clear.
Okay, great. Thank you very much for the invitation once again. I was lucky enough to be invited for the midterm crit when you started up this project, so I'm very excited to see where it all ended up with the structure on the rooftop. I understand that it started raining, but I hope we get to see. Otherwise, we get to see pictures of it, I suppose. So. Okay, before I find my presentation, let's see. I'm very excited to see everybody's work. I have deliberately, maybe I should say just a few words about myself. So I sort of have 1 foot or had 1 foot in academia and 1 foot in practice. And the project that I decided to show today very much reflects that, in the sense that it's an applied research project, which is built into affordable rental housing. I like almost, it seems like the rest of the panel here have a history in central London, in the sense that I studied at the Bartlett and I taught at the Bartlett and the AA for a number of years, but I now have my own practice together with a couple of other guys back here in Copenhagen. I moved back maybe 4 or 5 years ago, and we've been doing various things. A lot of it is timber projects. We're doing a mass timber project in Virginia at the moment, which unfortunately is on hold because of Corona, but probably will move ahead again soon. But I decided deliberately also to sort of broaden the range of projects that we're seeing here today, not to show a mass timber project, but rather another type of, let's say, at least I think, interesting approach to the use of timber and wood construction using digital fabrication. So I'm just going to go ahead and share my screen. I hope I'm getting this right now. Do you see the slide?
Yeah, looks good.
Okay, good. Just going to try and make it full screen. Right. Okay. So, so the project, as I said, is an applied research project, which we got a grant from the government here in Denmark, trying to address one of the issues which is not only an issue in this country or in Europe, but also globally, is the sort of the enormous amount of actually quite qualitative empty buildings that we have sitting around in the countryside, which is mainly due to two reasons. One is the rapid urbanization that we have obviously experienced in recent years, as well as the fact that, especially in Western countries, a lot of industrial buildings are left empty because production has moved to the Far East, which is the case with this project. So this is an old factory in the middle of nowhere in Denmark. It used to house a factory which produced blinds and curtains. But again, what happened is that the whole production moved to the Far East, I think like 20, 25 years ago. So the government came up with this proposal to give up a grant for coming up with ideas on how to, let's say, retrofit these types of projects. So this specific project or this specific building is just meant to be viewed as an example. We were more employed to produce a strategy on how to generally retrofit empty but quality buildings in empty areas. So it's an old factory in the middle of nowhere in Denmark, and the way we went about it, since I only have 5 slides, I'm jumping quite fast, but one of the targets was to employ digital fabrication and manufacturing techniques. So what we did is we started out by scanning the entire building. And what often happens, obviously, with older buildings is that it doesn't look like the way it did when it was planned out and the way that it was drawn. New sort of additions appear, it gets remodeled, things start falling apart here and there. And so it's actually extremely difficult to just go in and retrofit it immediately with clean methods, at least. So the idea is that we scanned the entire building, which would enable us to obviously extract exact data out of the model, and thereby produce precise, let's say, for example, in this case, I'm using the example of the partition wall, which is the simplest sort of component that we had, to get an exact outline of the wall to be put in place. And the other part of the project, which I myself find extremely interesting, is the fact that even though that, let's say, the objective from the beginning was to use and employ digital building techniques, since it's an applied research project, we knew already from the get-go that there would also be a process towards the end where we would have to hand over, let's say, building material for workers who are actually carrying it out using predominantly manual conventional building techniques. So this balance, to which extent it's actually does it make sense to employ digital building techniques versus conventional building techniques, is something that we try to plot out very deliberately from the get-go. So sorry. So what these diagrams are showing is that the strategy that we came up with, which again I'm using the example the partition wall, although it's much more three-dimensional in reality. You will see that in later slides. If you take the example of the partition wall, which has to cut through a series of, for example, Roman arches in the ceiling, which large parts of this building had, well, the idea is that you actually try and maximize the standard area, central standard area, so that it is divisible by whatever building standards that you have from, let's say, off the shelf that you can go and buy in any building market. So you would actually get the data from the contour and have the whole periphery CNC or robotically cut, and then the majority of it would be able to be fit with completely standard 122 by 244 panels. So the diagram on the left shows, let's say, the assembly sequence. So 1, 2, 3, 4, 5, 6, 7, 8. That's the whole periphery, is made out of digitally fabricated and precisely, let's say, fitted components. And then from 9 to 14 are just building standard, completely standard panels that can afterwards be installed very simply and very easily using manual labor. So in the diagram on the right, you can see that there's an interface between those two, right? So there's the conventional building method getting connected with the let's say the digital fabricated pieces. And you can also see that we're leaving out a small cavity in the frame for technical equipment such as hoses and pipes and electricity and so on. And so thereby we have this entire strategy on how to try and retrofit an entire existing building from the inside by creating a sort of linen or a lining almost on the inside, which is made out of LVL rafters and digitally cut CNC pieces that fit precisely in once you start assembling the pieces from the inside. So the process looks something like this. You would create a digital model that accurately describes whatever panels and walls and elements that you have inside. We test it against the scanned point cloud model, and then what you see on the far right image is a one-to-one mock-up which we did at the Oak School of Architecture. Just try and start to test things out, and it actually worked quite well. So it's a multi-layered sort of paneling system where you can either fit insulation or pipe work such as electricity or hoses or water pipes inside of it. But obviously after this process, things started progressing a little bit, and we as we were working towards the final product, where in the end, you actually end up with a slightly different. I mean, it's the same method that we've been using the whole way through. But as soon as things started getting real, we had to adapt, let's say, to the existing conditions, and also considering the fact that this is actually a rental space. We have created algorithms that actually calculate out how can you maximize the amount of standard panels versus the sort of CNC cut panels that we would use to fit out the spaces. So this is the result. It finished just I think maybe a year ago, 6 months ago, and obviously the idea is that this is a method rather than a final product. So right now we're working on a similar approach in another post-industrial building where it's becoming based. We're turning an old factory into a headquarters and an office space for a clothing brand. So yeah, so I hope that this sort of already since the get-go broadens the idea of what you can use timber construction or ideas of using wood and digital fabrication for.
Great, thank you, Kasper.
That that's the very, very, very short version. I have like a 200 slide manual, but I had to trim it down.
I appreciate the condensation effort. Yeah, super interesting. Also kind of the two approaches of one kind of super custom tailoring of these neuralgic, let's say, interface pieces, and then the using standardized sizes wherever possible. So very interesting. I don't know if I can kick you out or if you have to stop sharing your screen.
I probably have to stop sharing, right? Let's see. There. There we go.
Thank you. Teresa, are you ready?
I am ready. Whoa, hang on a minute. Okay.
There you go.
Can you see? Oh, what happened? Can you see my screen?
We do see your screen, but the full screen didn't really work.
Then I'm just gonna stay in the slides.
Oh, that's fine. We like
okay. So you see it now.
Or preview.
Okay, so thank you very much for the invitation. My name is Teresa Cheung, and I have taught in Alice for quite some years, spanning quite a long time back. And I am now the academic head, and I run it together with my colleague Daniel Zamerlied. And the chair of Alice is in fact Dieter Dietz. So we take care of the first year teaching program at the EPFL. And Alice stands actually for the Atelier for the Conception of Space. So as our name suggests, space is at the heart of our reflection, both in its construction and its conception. The first year is actually supported by many different structures. One of the most essential of which is this. It's a program, year-long program that spans over 28 weeks. And in those 28 weeks, we really ask the students to immerse themselves into what we call poles. And these poles kind of range from measures, then evolve into elements, evolving into planes, and then rooms, houses, and gardens. So quite kind of tectonic shifts in the idea of conception of space. And during this process, we really ask them to confront themselves with essentially three scales: the body scale, the architectural scale, and the territorial scale. We have a lot of students, usually over 200, 250, usually we start with, around about. So we have a very large teaching team of 10 people who come from various backgrounds, including architects, landscape architects, engineers, and artists. So what we work with are a series of what we call scaffolding elements, scaffolding in a sense of support, not just physical, but as you also saw now, the program itself. And throughout the years, we have worked with structures that basically foster collaboration because we have so many students. And within each studio, so they are divided into these 10 studios. They have to work individually, collaboratively in small teams, but also then amongst studios. So we have really a great range of scales of collaborations. And one of the physical and structures that we've always maintained in Alice used to be called a matrix, which stayed always at a scale of 1 to 33, which is of course an imperial scale that is very close to the foot, very much related to the body. But I think 6 years ago now, we developed that into a much greater thing called what we now call a proto structure, which is really what you see now on the screen, which is a 1-to-1 construct. And this protostructure, as its name suggests. It's kind of a pre-structure. It is not by itself stable. And it's really an extension of a constructible ground. So it allows students to inhabit it with projects, which in turn then strengthen and make more resilient its structure. Here you see a very small portion of it that was done in 2019 in a small French town called Evian. And it was actually quite amazing. It was carried into the lake on the Swiss side of the Lac Léman, of the Lake of Geneva, and then floated, hauled with a boat across to the French side. And the protostructure by itself, as I said, it's not really yet stable. So in this particular instance, it is those stabilizing and floating panels and the minimal cross bracing that is actually the project that exists in the protostructure. So I suppose wood, timber is really another crucial material that supports our pedagogy at Yates. Because of its immediacy, because of the tools, the simplicity of it, its ability to transcend different scales, model scale, full scale, and also, that we have a very great constraint that at the EPFL first years are not permitted to access the workshop. So we'd have to be able to do everything in our own ateliers, and hence I think the wood really helps us, or the tools that we use really allows us for that. Here you see a really full-blown 1-to-10 model of the protostructure that was devised for Brussels, which was in 2017. And it's really a structure that allows for students to negotiate and appropriate space and to articulate the spatial practices that are implied by their projects that they propose. And as I said, we have no atelier space, so everything has to be able to take place within the school ateliers. And here you see a series of mock-ups that are being tested, that is existing in a book that Alice published a few years back. But I think also for us, the tools or the manner, the attitude which we are faced with when we work with these, and we work very simply with it. In fact, we are often using like profiles of 60 by 27 or 100 by 27. So our attitude towards it is we find that it's very similar to taking a pencil to paper or a knife to cardboard. We also do a lot of casting, and then the saw to the wood. So we find that the attitude or the behavior is very similar, or it can be very well echoed amongst each other. And we also have, despite the last 3 semesters, which has really put all of this into question, we have for many years been teaching our students to draw by hand, mainly for its slowness, its ability to allow time to reflect on what the students they are doing, but also this very physical connection between what was speculated in the mind and then a physical act of bringing it out. So, these are the kind of tools we use. I guess the most crucial one here is the Japanese saw. Pretty much everything that we build is made with cut with a Japanese saw. It's only in the last 2 weeks that we have access to 2 kind of circular saws. Otherwise, it's the Japanese saw and a series of electric drills. And I think what is really great for us is that, we spend the year kind of thinking about how to conceptualize space. We work through a series of themes and topics, and then a lot of time planning projects, and then it all happens in the last 2 weeks of the year, where the prefabrication takes place. And one time it was hand carried 500 meters from the ateliers to a site on campus to be installed. Another time it traveled from Lausanne to Brussels. But we go to the lengths of even making the students draw how they would pack every truck load that has to go anywhere. And of course, I think we are often in very public places. This year we worked with 4 communes in Geneva, as well as the city of Geneva. So it was a lot of politicking around. But I think what has been really nice with the quality of this material is that it has always allowed us to be very sensitive, very light in the way we touch the sites. This is actually not Evian, this is actually this year. This happened a few weeks ago. Students were testing out a way to anchor onto this small bridge. And the concluding slides is just a series of the results of the past years. We call it the house series. Each of the protostructures for each of these years have been slightly different in dimension, but also in how the node has been conceived. This is house 1 that happened on campus in Lausanne, which was an open space. And here it's house 2 in Zurich, which was right outside the art school, in case anyone is familiar with Zurich. Which has this really high and very long highway that goes right next to it. And actually this is just the very start of a very, very long strip that travels all down this infrastructure. And then house 3 in Brussels in the old Citroën garage. That was another site condition again, that was completely an interior condition. And then house 4 in Evian. And actually it was at this moment that they started to fragment into pieces. So this is one of, I think, 6 fragments that was orbiting the Jean Prouvé pavilion as part of the Evian mineral water complex. So yeah, this is kind of what we do at Alice, and thank you for listening.
Thanks very much, Teresa. Very inspiring, and also I'm looking forward to the contrast that also we have here from the different approaches and kind of focus areas of our guests this evening. So from a, let's say, very crafty, hands-on classical tool approach, we're moving over to Martin, and I'm curious what you're going to show us. So far, no sound.
Apologies for that. Can you hear me now?
Yes, we do.
Great. So yeah, thank you for the invitation. Real pleasure to be speaking. I think right that I'm going to present a bit of a contrast to Teresa's presentation. I think maybe not so much that it's less crafted, but there's certainly less straight lines in these 5 slides. I think I'm just going to cover, I mean, just some little snapshots and just some thoughts, I suppose, rather than any sort of complete project discussion. I'm speaking a bit with 2 hats on, as you introduced me, from my sort of academic background with the AA at Hook Park, so woodland campus, really sort of timber focused and very much engaged, you know, much like Valldaura in the direct working with the wood and the local material. And then Xylotek is a practice that's emerged a bit from that with, I'm set up with 2 other directors, both people we all met through supporting the projects at Hook Park. I think, some lessons learned from working in that environment, but trying to bring that into practice that's operating, commercially and in the context of the timber construction industry. So sort of, interesting crossovers. I mean, this slide, I guess, is a sort of provocation. This is a 900-year-old timber structure that forms the scaffolding inside the Salisbury spire, the tallest of the spires in England, of those remarkable Gothic cathedrals. A lot of this timber itself is reused, so is even older than that. And you can kind of see, like, it's still functioning as a remarkable structure. It's got a huge kind of embedded capability within it. It's been built without contemporary understanding of engineering principles or machinery. Obviously with a huge kind of embodied knowledge of the craftsmen who built it. Sort of jump to one of the Hook Park projects, probably familiar to quite a few people, obviously relates to the work that IAAC have been doing more recently that Raimund presented. So I suppose it's taking, I guess, three kind of key elements, isn't it? It's an understanding of the form of the tree itself, the potential that 3D scanning is opening up to really capture digitally the inherent form of the timber, and the possibilities offered by robotics as a way of working with a regular material, but very precisely at their intersection points. So this is the product of one of the Design and Make cohorts. So Design and Make is a master's program at the AA, based on the premise that design can happen through acts of making. So in different scales, but very, very much working with wood, located at the Hook Park campus here. So the potential quite profound, that you're working with, I mean, literally the trees you can see in the background of this picture are the material for that structure, and really trying to exploit the particular inherent capacities that the tree has. It's a natural material. There's a deep kind of evolved capacity of wood. I think perhaps part of what I'd like to advocate here is that we shouldn't just be thinking of wood as kind of stuff that we use like other materials. It has these very particular internal structures that are a consequence of its capacity to grow, its capacity to transport water and sugars through it, its very particular responses to light and to structure. And we can either try and sort of average those out in kind of conventional engineering, engineered timber technologies, slice it up and glue it back together, or we could try and work with those qualities that are the inherent kind of, developed characteristics of wood. And I think, I guess something that this project is trying to capture is, that there is this sort of alternative view of wood as something where you work with its characters, not seen as deficiencies, but as potentials. Maybe talk a little bit about the practice. So we formed it a couple of years ago. We're based in the UK, but with some of our staff in Berlin and in France, and sort of distributed. So hoping to be a kind of dealing with Brexit, sort of Anglo-continental practice that can, I guess, work closely with both the UK design community, London and along the sort of Bristol-Bath axis and around the country, and with particularly the Central European fabricators, where there's obviously the core sort of dominance of the technical capability in a larger scale production. And we run a little workshop in Bristol. So I guess fundamentally, like, my co-directors have both come from making backgrounds and deep sort of embodied knowledge of working with wood, trying to kind of marry that with the technologies, and running a workshop where we do sort of smaller scale stuff. So sort of I guess the prototyping and the smaller, more hands-on stuff to keep a sort of feedback between the consultancy work and the made work. So we're quite young, but we're working at a bunch of scales. I mean, the blue things we've completed, the yellow things are actually all kind of now more or less on site or close to completion, and the grey things are things we've consulted on or are now kind of through design stages seeking to deliver in the future. This is the project. This is on site now. This is taken on Friday of a little, it's a small little project, but quite a bit of work just to sort of refine how you develop a single layer grid shell in a way that works sort of in sympathy with the material. So it's going to be glazed. It's a sort of semi-internal space glazed grid shell. Each lath is formed geodesically, so it's working with the wood hopefully as efficiently as possible. So taking these oak lamellars, which are straight laths, straight lamellars that then just bend in their sort of minor axis sense and twist to take up the shapes across this doming form. So it's quite a neat technique for getting sort of the material to work in sympathy with the geometry coming together. And the final slide, bit of a teaser for a project that's just finishing up in Paris, not yet in the public domain, but this is smaller scale pavilion work, work with steam bending, so a magical process of plastically transforming wood's form. This is with ash. We do, it's interesting to sort of argue, I guess, about the sort of pros and cons of the industrialized sort of paradigm of the timber industry. I think Katara was mentioned earlier. I mean, the move towards kind of major industrialization obviously has its benefits of economy of scale, but perhaps is also risking taking away the ability to kind of work closely with the material and work, there's, in the 21st century, we have other potential to work with more distributed modes of manufacture and to bring our technologies to the material, and not necessarily to pursue a major centralized, approach to production. So this was nice. We went to the sawmill, we saw the trees, we went to the sawmill, we selected the pieces of wood very specifically for their qualities, looking at the grain, the kind of craft sort of aspect was very much in there to really understand, to test exactly, which sort of parts of the tree, which sections would work well, through this free form steam bending at different scales. Yeah, I'll end there.
Thanks very much, Martin. So there's like this kind of comeback of the, let's say, embracing the inherent material properties that the kind of the industrial treatment that got lost from the standardization and industrialization, and now kind of is coming back thanks to these new technologies and being able to incorporate all these, like first acquire and then incorporate all this information into a design. So I think that was a beautiful example of it. I also I really like the parade of weird timber creatures that you had there. So yeah, next time, like if there's a limit on slides, I think I will do the same and just put all the projects together on one like that. So now I'm curious how Manja was handling our slide constraints or not.
Or not, exactly. Actually, yes. So I was one of the ones that said we have to do 5 slides. But yeah, I have also 15. So Teresa, I think we are good here.
Wait, hang on. I checked this with Raimund about like 3 hours before this event. Who just said...
Whoops,
yeah, of course.
Who approved the 15 slide?
Obviously, 5 slides is a bit tough. We're happy to see as much of your work as we possibly can, and we will also try to look a bit at the clock while we're doing it.
Yeah, I will try to be quick. I'm going to share now. Here we go. Yeah. So timber, your reliable friend, is my title here, when it works together. So actually, I just want to talk about timber and how it works in collaboration with other materials or systems. So the first one, unfortunately not done by me, is a project by Arab. That is actually the cork house, so the engineers are Arab. Just hold on one small second. Sorry, there was hoovering at the same time. So I just paused that for a minute. So what is important here is that timber is actually working together with cork and kind of thinking kind of differently as this kind of timber structural wardrobes. So this is the cork house. You must have all seen it. It's really about design for disassembly, reuse, kind of recycling, etc., and obviously trying to use a new material. But here timber is its reliable kind of friend to cork, because actually it has this, as you see here, where I'm pointing with my cursor, structural wardrobes that ensure that they could actually use an unfamiliar material. So in some cases we try to push the boundaries of timber, but in other cases actually it can also allow us to use this material in order to push boundaries of other materials. And I thought it was quite great. So if we are thinking about this way of friendship, this is another project where timber is thought of collaboratively with concrete. Yeah, and it takes two to tango. So this is a project that I did together with Adrian Campbell, where we created together with Thistleton a feasibility study to create a combined concrete and timber high-rise structure, so 23 levels, around 72.5 meters tall. But what I want to say is that when there are two people dancing, so in this case timber and concrete, obviously there's not one way to do it. And obviously we can think of different kind of hybrid systems. So is the glue lamp with CLT infill structure, or is the clear span CLT that actually spans directly from the perimeter to the concrete core, or is it all cross-laminated timber? So here it says that the timber volume is obviously increasing, but actually what I want to say is that, you know, it's not all that black and white, because, you know, for each of them, obviously there are kind of pros and cons on how they kind of work together. And perhaps in the first one, where it has glue lam and CLT kind of infills and CLT floors, maybe the whole kind of buildup is thinner, but there needs to be much more coordination with the kind of downstand beams. Or if you would go for option 3, which has an all CLT structure, which can be really fabricated offsite, then we still have issues on how to combine then the concrete CLT with the concrete and the CLT when we are looking at creep and shrinkage of these two materials. But because it's not also black and white, actually this is really great, because if you're thinking about, let's say, kind of two materials or two approaches combining, in this case, an OSB kind of block system together, so the block system, which is called cassettes in this case, that is developed by Mass Bespoke, which I worked on as well. It is actually combined with other standard elements. So similar to the first project where I talked about cork and timber, in this case, it's standard timber elements, either here shown on the left-hand side as beams or in the right-hand side as vertical elements, columns, that then work together with a lesser off-the-shelf kind of system. So this kind of dialogue between the two, I find really interesting. Then not only timber to timber or timber to concrete, but if we are looking at, for example, steel, this is another project. Actually, it has been done with masonry bricks. But I want to just showcase it also as an intention where we can bring together, in this case, this kind of very thin metal strip that then is going to get infilled, which could be with timber blocks. So where normally we would have beams been created as a kind of solid timber element, as we saw in the images before, we could be again thinking about, instead of bolting it together, which we know is not very efficient for timber, we could think about an infill kind of hybrid structure where again, the two benefit from one another. So more of this kind of timber blocks, and you see here like almost this piano wire running through, is a project that I did together with Kasper, who presented first in this, and also some of you guys, so Raimund and Tom were also there to collaborate actually in this think tank, where we created this dialogue, let's say, between kind of cassettes. So again, this kind of volumetric timber blocks, but then with post-tensioning elements. This is all obviously about later thinking about design for disassembly, but also about being creative with post-tensioning, and also here saying maybe being a bit messy. And I think this is really great. We worked here together with students and professionals to kind of come up with this system and to try to develop it. And I'm all for messy because it just means that, yeah, we don't really know yet what the outcome is. So it's quite nice to explore. All done at Grimsdijk farm just outside of London. So then going into the final kind of project that I want to show is by Hour. This we just completed, but also has already been disassembled. It has been up for about a month. And again, you see the reoccurring kind of timber blocks. Yeah, there's a lot of research and kind of development that I have been doing with my practice about kind of developing those and obviously trying to make them span. So here, again, the timber blocks are tied together, but not with cables, but actually with rods, as you see here in red. And we can make all of this kind of connections. Obviously, we have done some kind of simple testing. But I think what is important here is that this design for disassembly also asked about something else, where before I said, it might be good to have your standard timber that we all know. But in this way, we are actually saying we have been using in this structure more lazy and more active blocks. So the lazy blocks in this configuration have not been doing so much structurally. So we know that they haven't deformed, or we really still know that, you know, they're closer to their initial strength. So when we are disassembling and reassembling, we are assigning the lazy blocks to become the hardworking active blocks, and the previous active blocks to become the lazy blocks. So again, kind of thinking about this kind of dialogue of how we can strategize this kind of collaboration. So yes, just to finish with the slide, timber is your reliable friend. Obviously, I've been showing you kind of options and ideas of how it can really work together. And here you can see, a quite long span just made of these blocks together. And they were also proud kind of sitting on it, which I thought was a nice way to end and to tell you this little story about our reliable friend, timber. And that's it.
Thank you, Manja. Unmistakably Van de Worp presentation. Thank you very much. And like a lot of work that I haven't seen yet. And let's say, when we think about architectural vocabulary that now becomes, that now expands, that is based on timber, I think we've seen like already quite a lot of the potential from blocks to tree branches to standard elements, etc. And I think we will see more. And now it would be Steve Webb, if you're ready.
Hi.
Hi, Steve.
So I didn't read my email about the 5 slides. Kind of way over, but I'm going to talk quickly in compensation. So we're Webb Yates. Can you hear me okay? And can you see this?
We can't see it yet.
Sorry. Now?
Yes.
Yeah.
Great. Yeah, so we're Webb Yates. We're a multidisciplinary practice with M&E engineers and structural engineers all mixed up. There's about 60 or 70 of us, I think. And I think in most circumstances, I don't feel like a very commercial person or the owner of a very commercial practice, but after all of your presentations, I am really feeling like the Tesco's end of this conversation. We work on all scales of project, from very small timber Strathskin timber shed on the left, right the way up to really big infrastructure projects at Heathrow Airport. So that's a 190 million baggage handling thing under the taxiway at Heathrow. And we've had for a long time a kind of drive for sustainability. So we try and make things out of timber whenever we can. We try and make things out of stone. And just kind of inherently try and make things more sustainable. But a lot of the projects we do are not sustainable, don't have sustainable clients, aren't in sustainable environments. So, you know, we try and bring sustainability to reluctant recipients most of the time. In timber, Manja has slightly stolen my thunder with her tango of concrete and wood. I think we are really, I mean, we try and push for timber all the time, and we're really struggling at the moment with fire and you know, lots of arguments against timber durability and all kinds of things. And I'm thinking a lot of timber projects are going to die because of this, and there's not very much support from the timber industry in terms of overcoming the problem with fire, particularly in the UK because of Grenfell. And I imagine maybe it's not hasn't reached quite that level of inspection in Europe. It sounds ridiculous, doesn't it? But so we've been looking for a number of years, looking at mixing and hybridizing timber and concrete. So this is a small art school in Wimbledon College of Art. So we designed the M&E and the structure for this, and we're trying to find a solution for the structure that suits the M&E as well. So if we have a building with a little bit more thermal mass than a normal timber building, then we don't have to have any air conditioning. So this building is designed with passive house principles, and it has concrete, 2 floors of concrete, very thin concrete slabs on a timber frame. So we're kind of mixing supporting concrete with timber and using the concrete to absorb heat from the building and thereby not have any air conditioning. We've adopted this as a principle, and we're doing several more projects like this, but this is the Anna Freud Foundation in London, which is a £17 million office building with various components, but a big part of it is the timber frame on the right and the left. And here again, we're building a timber frame with composite concrete floors. The building has, again, no air conditioning because of that layer of concrete. And the timber is connected to the concrete in a composite way. So when the timber beams deflect, they squash the concrete. The concrete works in compression and the timber works in tension. In this case, it's a Baubucher frame. So those are all exposed in the inside of the building. So I also, like Manja, think that some kind of hybridization of concrete and timber is a good idea. The regulations in the UK now are that you can't have a timber or a building with flammable materials in the facade above 18 meters, and they're thinking about reducing that to 11 meters, which means that any kind of mass timber multi-story project is going to be quite difficult to have timber in the facade. So mixing concrete and timber is quite a good combination for high-rise buildings. And actually, when you look at the volume of materials in a building, so this is very similar. We were looking at a 14-story building, and very similar to the one that Manja was looking at. The bigger volume of material is in the floors, very little in the facade. So actually, if you have vertical concrete structure, you overcome the fire problem, you overcome axial shortening and stability problems, and you use the concrete in compression where it's quite efficient, and then you have all the floors in timber. The negative carbon of the timber far outweighs the positive carbon of the concrete, and you use the materials in ways, you know, to their strength. The typology of precast concrete and timber, mass timber construction are really, really similar. The two sets of people never talk to each other. They have nothing to do with each other. They never work together, but actually their operations are really similar. So we were thinking that trying to bring a precast concrete manufacturer and a timber manufacturer under the same envelope, no main contractor would ever employ 2 separate subcontractors to work on something which has layers like that, because they always fight over the crane. You need them to be the same company. And so we're kind of advocating for them forming joint ventures for those sorts of jobs. So we've had a go at a very small one of these, not the precast version, but this is with Amin Taha in Islington in North London. That's in situ concrete cast in CNC cut molds but actually inside there it's a completely timber frame. So we build the entire timber frame first. Building the frame first means that you don't have the fight over the hook. So the concrete guy needs the hook, the timber guy needs the hook. You need them on site at separate times. So we built all the timber on temporary props and then build the concrete around the building afterwards. And then take all the props out. So you have this kind of hybrid frame. And finally, we do loads of work with stone. And stone is a really powerful low carbon material. And so I think the next step in our kind of explorations and a couple of projects that we're working on at the moment are hybridizing stone and timber rather than concrete and timber. So using stone floors above timber beams. We've done a lot of R&D in stone. We're working with UCL, people like that at the moment, reinforced stone. So I think kind of, yeah, timber won't work for everything. But maybe timber and stone are a really good combination for a kind of more sustainable building vernacular.
Great, thank you, Steve. For me, is an interesting kind of angle to see from, even if you don't consider yourself the commercial guy, but let's say from very close to large scale projects, what is kind of a more pragmatic but still innovative role of how timber can kind of find a place where it still creates this sustainability benefit, but also through this combination with other materials, you are not suffering, let's say, from its shortcomings. So that I find super interesting, and it seems to work really well. So the last presentation now is from Tom Westwood from Waugh Thistleton Architects. And Tom, if you're ready, please take it away.
Yes, sure. Thank you. Thank you, Raimund. Okay, so yeah, I hope everyone can see that and hear me okay. Yeah, thanks again, Raimund, and everyone for the invite and for all the presentations so far. Super interesting, and yeah, a lot of themes and that I will perhaps touch on as well, both similarities and also differences, which I think is the point of these things, isn't it? To covering a range of approaches. So I'm talking to Steve's point, perhaps, about going to the most commercial project. I'm not sure he was. I think I'll compete with him for that. So the theme of my talk really is mass timber, mass market. I certainly, I think, anticipated that quite a lot of the projects shown today would be more about craft and the particularities of materials, both in their raw state, experimental structures and discovery, and I think therefore interesting perhaps for me to show what we concentrate on more at Waugh Thistleton, which is trying to make engineered timber of various kinds into a completely normal everyday material, something that people use all the time, and don't see as scary or dangerous or something that they need to worry about, but see as completely normal material, with the eventual endpoint that people see it as what they should use for everything, as opposed to other materials which are more carbon intensive. And exactly as Steve said, a lot of that journey that we're on means a lot of persuasion, a lot of sales, a lot of compromise, but that's all part of the journey. So how do we do that? We obviously build, as an architecture firm, we design lots of built projects, which I'll show a couple of. but I think it was also interesting in a session like this to talk about what else we do and the other ways we have to work, or we feel we have to work to move forward the cause of mass timber. One of those is advocacy. So, talking about what we do, talking about the material, its pros and cons, how it works, events like this, but also doing things like this, like drawing a cartoon that perhaps is more easy for some people to understand, perhaps has a wider reach, maybe is more eye-catching, something you can publish, something you can put on Instagram, something you might get in a newspaper, and using those various tools to try and spread the word about the possibilities and the principles of mass timber, because there's a lot of misinformation out there as well, and a lot of other people with other interests, completely understandably. I would say one of the main challenges to more timber being used are the concrete industry and the steel industry. And whilst there are great opportunities to work together, exactly as Manja and Steve were just showing, and use those materials together in structures, it can also be quite a adversarial industry. So actually trying to spread the word about some of the more of the facts and figures around timber, I think is very important. We're also increasingly doing more research. We definitely didn't set up our practice as a research practice. We wanted to build things, but we are doing more research. I think we see the importance in that. Again, to educate people, to educate ourselves, firstly, to look into the particularities of timber, how it performs, in ways in which you can use it both technically, but also in terms of legislation, which obviously varies from country to country and changes all the time. As Steve was touching on, particularly in the UK at the moment, the fire legislation is indeed very challenging for timber. And to spread the word. And it's great that there are lots of people out there who want to invest in that research. The largest project we're working on in that field at the moment is for the European Union, called Build in Wood, and is really trying to, it's a 4-year project, very long project, lots of partners, and really trying to develop different rules, connections, kits of parts, and guides and helps, guidebooks really for the industry and for developers, for contractors as well, to persuade them and encourage them that wood is a good option. Also trying to expand in our work into different sectors. So we've been working with engineered timber for around 15 years now in the practice, and much as Steve said, we try to make all our projects timber. Don't always succeed, but we've had, over the years, we've had most success perhaps in housing projects. But in more recent years, we've really tried to expand into different sectors more, to try and again prove that timber can be used in those as well. So this project is a few years old now, but is an industrial building in the UK, with, I must say, a client who really wanted to do this as well. So which was a rare treat to work with such an enthusiastic client. So we weren't having to do all the persuading. But I think it proves that an industrial building can be built with mass timber. And this is not, for anyone from Germany who's familiar with German buildings, this is completely normal in Germany. They have loads and loads of timber industrial buildings, modern buildings. So it's not this is not radical in global terms at all. It just so happens to be quite unusual in the UK. But again, trying to really persuade people what can be done. Also working on more and more office buildings. So we've completed some in the UK now, and are now trying to work more broadly in Europe. This is a project which is at quite early stages in Amsterdam in the Netherlands, and combines a large-scale timber structure for an office building with also retaining the majority of an existing concrete office building structure, stripping it back to the frame and then building on top of it and next to it, and demolishing a small part of it where it's incapable of supporting a great deal more weight and where we want to build a much taller element of the structure. But also working on large timber office buildings in Milan, in Italy as well at the moment. Also then back to housing, but trying to do housing in a slightly different way. So over the years, we've generally built housing projects with flat cross-laminated timber panels, coming to site flat pack and then being erected and joined together. But over the last few years, we've also been working with a housing association in the UK on modular timber. So again, modular, not a new idea at all. Lots of modular housing is built and hotels and student housing. But it hasn't really been done before with cross-laminated timber panels for the walls and the floors of those modules. And it's a great material for that. You know, it's robust, it's rigid. It doesn't move around in transport so much. When you're building the box in the factory, you can climb on top of it and drill into it and so on. So it's actually very suitable for this, as well as being relatively lightweight compared to, say, concrete, which is sometimes used in modules. And also trying to expand our thinking a bit more into disassembly. So traditionally, when we've worked with cross-laminated timber and glulam and LVL as well, it's very typically screwed together as elements. And whilst you can take those screws out, you know, you're obviously drilling into, you're damaging to a certain extent the wood by doing that. So trying to look more in projects now at how we can make elements that can be disassembled and reused more readily. So this project, this is the third incarnation of a pavilion project, which was originally in London, then rebuilt in a different configuration in Milan, and then this third configuration in Madrid in Spain, and is really trying to promote the use of mass timber, educate people in what it can do, that it exists in the first place, because we fully understand that most people wouldn't know what CLT was and have never seen it. So really trying to get people more familiar with it, raise their interest. And we also took this opportunity to work with a fabricator who actually made these panels in the UK. It's American timber, because the client was the American Hardwood Association, but the timber was shipped over, and actually the panels, the CLT was made in Scotland. And CLT had never been made in the UK before. So that was, again, a great opportunity to show that it's possible, admittedly on a small scale, but to prove and engage more people with the process. So all these panels are bolted together rather than screwed. So it's, very easy to disassemble and move around. So that's me. Thank you very much.
Thanks a lot, Tom. The kind of large volume mass market potential of timber and the kind of environmental impact that comes simply from looking at huge volumes, I think is something that will enable this material to contribute to a lower carbon construction industry. And I'm very happy to see, let's say, on this in these examples, like how this is successfully applied to rather large scale projects. So because like what we are used to doing also here at IAAC, yes, we do kind of one-to-one prototypes, but it's obviously still usually on the scale of prototypes. And while we're investigating what could be, potential future uses of timber, we're hardly directly, let's say, involved as architects in designing buildings which actually employ this material so that it has directly an impact. So I'm very happy to see this this angle kind of brought into the discussion, both from you and also and Steve. So now it's actually already 7:30 here, but before we jump into the presentation, I think we should have the chance to have a little bit of a discussion before we see the presentation of the rooftop pavilion, structure, and I would like to start maybe with Teresa. In your presentation, like one thing that struck me was the let's say the very physical connection or relationship even to a material that makes it so suitable for, let's say, from an educational perspective. Like, it's something that immediately people can relate to and people can work with. And I was wondering like how I mean, can you even imagine this this kind of first year teaching to do it with anything else? So if you, for some reason, you would not be allowed to use timber anymore, like, what would you do?
Yeah, I think this is a reflection we've had a lot. I think over the years, as has been shown in a few of the presentations now, we have started to experiment with other materials. So we have also used concrete. We've also had bricks, and we've had rammed earth, and in all sorts of variations. But I think in a way, this idea of the protostructure is for us in this moment now quite inextricably tied with kind of this balloon frame, wood and timber structure. So I think in terms of how the projects manifest themselves within that, I think this is opening up now. I think what has also kind of changed a little bit this year is that we work in an area of Geneva where there's a lot of forest, and we have also been reclaiming logs together with a forester and a lumberjack and an architect who now operates a mobile sawmill. So it's been really interesting to work the materials slightly differently from what we had done before. But yeah, I guess we leave a lot of it to our students, and actually it's quite often that they come with these other type of material explorations. But I think for now, yeah, we have not reflected on what an alternative protostructure would be and what an alternative material for that would be. And
yeah, like from my or our experience here at IAAC, it's also, I don't know, it's very rewarding in the sense that you can build something. It's on the one hand, it's kind of an approachable and accessible material. On the other hand, you can do kind of serious stuff with it, and that makes it like kind of a smooth, makes for a smooth learning curve. You know, from doing something that is explorative to doing something that actually really works.
I think for us, it's kind of getting to that stage of having something that is seemingly stable, but actually is quite fragile. I think this is the moment where students can really explore, like, you know, how they would develop their projects, both spatially and constructively within this protostructure, is exactly in this moment of fragility. And I think for that, timber is really excellent.
So I said before, like, you know, as a moderator, you try to stimulate kind of a debate and be a bit pokey, but I said, like, you know, to highlight the contrast between you and Martin's presentation. I said something like, you know, like you have a very crafty approach, but actually the craft is in both styles, or both, let's say, ways of working with timber, either well, using your hands, or understanding the material, let's say, from a digital standpoint. Question to Martin. So where do you see, or let's say, this digitization of material properties that then feed back into a design, and especially also seeing now, let's say that the closer to the real world, if I may say so, larger projects that Tom and Steve have shown. Do you think this is something that also, think about regulations, etc., this will make it out of the Hook Parks and Grimsdykes and IAACs of this world into more commercial, larger applications? Or will we resort to shredding timber down to chips and neutralizing its material properties?
Well, it's a very good question, I suppose. And like, I genuinely would hope that there's a space for it. You know, there's obviously, you know, there's commercial, economic realities that I suppose favour the, you know, the sort of the approach that's emerged. But I think there are, you know, there's a broader evaluation, probably, isn't there, about what we're doing. You know, I think there are concerns out there emerging about the scale of, you know, of the mass timber approach, and the, you know, the implications for forestry, and how that is done in a long-term sustainable manner. You know, if we can, you know, obviously we're all advocating the use of wood, but it does have consequences, and, you know, I think somewhere in the mix, a sort of total evaluation of, I suppose, the ecology of the woodlands, you know, the implications of I suppose, you know, an approach where it favours monocultures, possibly. You know, and I think there's life cycle considerations as well, aren't there? I mean, you know, whether material that's got layers of glue within it is as sort of reusable, or has a, you know, what you do with it after the end of the building's life cycle, and how you ensure that the carbon doesn't, you know, quickly return back to the atmosphere, I suppose, on a, you know, on the sort of 100-200 year cycle. So I think there are a bunch of sort of bigger, you know, kind of global systematic economic questions that are still out there to be answered, aren't they? And, you know, I think that, you know, the work at Hook Park is obviously, it's you know, it's done in a kind of a, you know, in a sort of artificial environment where you do happen to have, you know, there's a different economy of, you know, of labour, because the students are there wanting to physically work, and, you know, the immediacy of the trees and things obviously aren't immediately upscalable, but hopefully there's a kind of provocation that comes from the work to at least remember, I suppose, that there are those kind of alternatives. You know, like, I think, you know, with Xylotek as a practice, we're daily almost kind of trying to deal with that. I mean, we are working on CLT projects, and we're, you know, working on a large demountable theatre now, which I guess relates a bit to some of the things Tom was talking about. You know, how you deal with the project that doesn't want to use screws, I suppose, and what that means for how you detail it. You know, and then sort of, you know, some of the smaller scale projects which are, you know, there are clients who want to work with timber that hasn't been imported, hundreds or thousands of miles. So I think there's a bunch of arguments for having a commercial role as well as just an experimental one, I'd say.
Yeah, and we're certainly hoping to see these things that get developed in relatively hermetic academic bubbles, that at least they stimulate also a discourse and an awareness of these technologies that will hopefully sooner or later also be more popularized through that. I'm also thinking, like, for example, I mean, timber is like a huge business and a huge industry as well. It's not just kind of the innocent, nice savior material that we might romanticize it to be. So there is also interest in how for example, infrastructure for timber processing is designed and is still kind of largely designed to make standardized pieces. So what we are doing, or what you're doing with putting saws on robots, etc., is still quite far away from kind of these huge volumes that like the Hundigers and the I don't know, Ledineks of the world kind of can put through. I found quite stunning that the wood chip barn is kind of the inverse approach of what Kasper was doing, having this interface between the very well-defined geometry and the kind of wild part that needs to be scanned. With Kasper, it was kind of the interface with the building on the outside that then allowed to use the standardized panels wherever possible, whereas in the case of the barn, it is the kind of interfacing detail between the branches where you have that precision, and the rest of the part is kind of rough and wild. But I see a reoccurring topic kind of here, which is how to tame timber. So we might as well maybe have called this roundtable Taming Timber. On the one hand is through getting a lot of information about the material and using it in an informed way. Another one is the hybridization that we've seen in what Steve was showing, and also Tom and Manja actually, combining it with other materials to allowing it kind of to do its best where it's most appropriate. So I don't know, question to Steve, like, do you think this is the way to hybridize with other materials to kind of sneak the amount of timber into commercial projects that would offset the carbon footprint of construction, or
yeah.
is there other ways of kind of having more pure timber structures?
Yeah, I mean, I think too much timber might not be great. If you displace all of concrete in the world with timber, we'd have a huge amount of intensively farmed monocultural forestry, which probably isn't a good thing. I mean, as I said, we were thinking about, we definitely have to give up carbon one way or another, that's for sure, but maybe timber isn't the only answer. So we were thinking combining timber with other things where they play to their strengths might be good. Anecdotally, as I said, we work with stone a lot. Edinburgh is a stone city, and you can see it's quite a big city, and all the buildings are constructed with stone. The quarry for the stone in Edinburgh is underneath the Sainsbury's car park. So there's this tiny little, if you look at it on Google Earth, this tiny little point that produced all of the stone to make the city. When you look around Edinburgh, there are all these dark green rectangles of intensive pine forests for forestry. So you use a lot more land to use timber than other things. So I think it's definitely going to be necessary to mix it up with something else. I think we mix it up with concrete because it's kind of palatable and it's a good. We have to lead, you have to lead clients are very conservative. They've got all these insurers and all these other people and costs, and every contractor is so set in their ways. They want to build with concrete. And so a kind of halfway solution is a bit more saleable. Yeah, I don't know. I think, the construction industry at the moment is very diverse. It's going to continue to be diverse, and not everything is going to be made out of wood. I don't think that's the only solution. I wanted to come back on your earlier discussion though. CNC, is CNC good?
You say CLT or CNC?
CNC. Everyone's gone CNC mad. All of my students, they want to cut everything with CNC. I think there's two sides to this. One is Martin's thing about scanning the tree and using the tree in its best possible configuration. That's amazing. That's totally great. Digitization of timber. Displacing labor by machinery is not very good for society. So replacing tradesmen and craftsmen with robots with saws, I think is a terrible thing. And I think it's really bad for employment. It's really bad for, it's the unmitigated use of materials by automation. It's quite bad. And yeah, I think that's definitely a two-sided argument, the CNC thing. Everybody loves it, but I think partly, as designers, we don't like to have craftsmen telling us what to do. You try and tell a carpenter to do something and they're like, oh no, you don't do it like that, you do it like this, but here you just tell the machine is totally obedient, and I think that's the temptation of CNC. But societally, it's going to disemploy a huge number of people. Robots don't pay tax. Sorry, just to throw a more controversial point into your discussion.
Thanks for that. Martin, would you like to respond?
Yeah, I think I formally agree with the political point. I think, I don't know, in the sort of the longer version of a presentation, I'll probably tell the story of when we were doing some pavilions of with FinForest sponsoring us, like cutting up, I think in the end probably thousands of plywood sheets and bits of Kurto, and sort of, I guess, maximizing what we could do with the CNC machine, just cutting subtractively, panel products into shapes that you then stick back together again into something that was, somehow more sort of architectural than the original panel. And there was definitely something very kind of wrong and perverse about that as an exercise. I think just, subtractive machining is obviously just wasteful by definition, but also just, taking material that's been, sort of sliced up, glued back together, shipped around, and then using the fact that you can program a machine to cut shapes to sort of abuse that material back into some other form. It's definitely something problematic about that. I don't know, the sort of the argument about where society heads if we continue to mechanize. I don't know. I'm not sure. I guess there's different takes on that, isn't it? But certainly the signs would be that it's probably not a good thing for society to overdo that. It's probably one to discuss over some pints of beer, Steve, some point in the future. But a nice question to raise.
I see also another development, which is kind of through trying to figure out how to automate, for example, Japanese joinery or stuff like that, or like something as simple as as you know, putting sticks together in space with a robot. There is also kind of a, let's say, a new appreciation of this craft, because what we can do with our hands is just so damn good in comparison, and it becomes so like the simplest thing becomes so damn difficult if you try to mechanize it. Just to give another kind of, you know, angle to this one point, I was wondering now if we have maybe some questions also from the people here in this room, now that you've worked a lot with timber yourself, like what do you think about it? Would you rather have CNC machines do the work for you, or would you rather take the Japanese saw and learn how to do a super nice precise detail? Also, I see like one question here from a viewer here on Zoom. So what do you think, Daniel?
Well, I was lucky enough to have to cut a lot of beams with a manual saw, and I can say it wasn't a pleasant experience. But yeah.
So where is kind of this dull, dumb, and dangerous kind of types of operations? Let's say our robotic overlords are welcome. Any other questions? Now is your chance, guys, before we switch to your presentation.
I have a question, maybe as a reflection on this unpleasantness of sawing.
Please, Teresa.
Maybe I could pose it just to the students, because I think what is slowly alarming me at also on different levels, scales, in different fields, is this notion of disconnection. And I do wonder, you know, not that everyone has to wield a saw on wood, but this notion of being somehow connected to the things that we build with or live with or use, whether this, at least, you know, having experienced it, how you develop that connection to a material, because to not experience it at all, I think, is also problematic. So I don't know, I pose this to the students. I mean, do you not feel like there is a certain connectedness in how you work with something, or, you know, when you hold something in your hand, when you hold this wood in your hand, that it comes from a place and that it behaves in a certain way and that, you know, you would not experience otherwise?
I think we will, well, now they're shy, but I think we will see in the presentation that there was quite a lot of very intense physical interaction with the material. I don't know, did you enjoy it or did you not enjoy it?
I mean, it was fun, but it is a lot more inaccurate and very intensive. Like, okay, with the tools for cutting, it works. Sorry, with the tools for cutting, it works. But when you use a hand saw to cut with your hand, then it gets a bit inaccurate, I guess.
So you're saying, yeah, like it gets inaccurate. It takes practice, and it takes kind of this craftspersonship to be able to pull something off by hand. That's why it's true sometimes, you know, like to do something by hand, also to expose maybe the you know, the not being experiencedness is something that people tend to shy away from. So there's kind of a breed of students, luckily not anymore because we put them through this workshop, that would just love to design everything and press play on the 3D printer and go home. But it's also a very different kind of projects that comes out of this this mindset, I think. So I would propose at this point we take a look at the presentation about the rooftop project, and then I would hope that that the speakers can stay for a little bit longer to continue the discussion, also with some questions that we have now here from the audience. So let me show first a video, and then we will have Laukik and Michelle give us a quick overview of the project. In the meantime, if people would like to drop messages in the chat, you are more than welcome to do so. We try to get back to them later.
How can we explore structural design through computational analysis, physical prototyping, and digital fabrication? The Data-Informed Structures seminar investigates how digital design and simulation, together with hands-on experimentation, can help to create innovative and enjoyable structural designs. Applying specialized computational tools, such as Caramba, to a real project. Verifying structural behavior through one-to-one physical prototyping. Creating and building a new structure on the rooftop of IAAC together. It tackles technical questions of structural design, joinery, fabrication, logistics, assembly, and teamwork. Timber is applied in an unusual way, using it for tensile elements. Timber in tension. To transform the IAAC rooftop into an environment that can stimulate social interactions, a place for meeting, exchanging ideas, hanging out, discussing, shifting perspectives, learning, having lunch, and an enjoyable small escape from the intensity of student life.
All right. And I'm now giving the floor to Michelle and Laukik for their presentation. Bear with us for 1 second. All right, all yours.
Thank you, Raimund. So good evening, everyone. You have already had a sneak peek of the new rooftop through the video. And now myself, Laukik, along with Michelle, would like to welcome everyone that is present here today, physically as well as digitally, for the inauguration of this new rooftop. So it was developed as a part of the Data Informed Structure Seminar class of 2021, guided by the very best Manja and Raimund, along with Deepika, Eduardo, and Shyam, of course. Okay. The structure that we are unfortunately not under today due to bad weather is the result of the workshop. Is the result of this workshop that revolved around doing a lot with little. We think it could not have turned out any better, but wait, it's a grid with some timber pieces supported by 2 portal frames. Is that it? Well, there's a lot more to it than meets just the eye. What is data informed structures? To put it simply, it's a seminar that bridges gaps between the digital and the physical worlds of computation, from design, analysis, optimizations with plugins like Karamba 3D for Grasshopper to fabrication, assembly, and building the structure itself. While looking at doing a lot with little, we looked at Frank's Cafe in London, a light deployable membrane spanning between 3 rows of timber A-frames made a rooftop happening. I think it's the epitome of doing a lot with little, really. So coming back to the site we had at hand, we went ahead to look at the environmental and the structural factors that were going to guide the design. So moderate northbound winds throughout the year and harsh sun from the south in summers, along with views of the Puade Street, were the major design drivers. This brief was opened up to the students of the seminar as a small internal design challenge, and we could very easily have had one of these proposals on the roof, which explored various structural systems from tensile fabric structures, space frames to continuous surfaces. But what really was unique about the one that was chosen was that it used timber, a very conventional material, in a completely unconventional way. Timber, as we know it, most prevalently is used either in pure compression in cases of vertical elements as columns, and a combination of compression and tension as beams or trusses, but seldom used in pure tension, and that is exactly what we are here for today. We also looked at sawmill shelter from the AA Hook Park, which is a structure that proudly demonstrates the capabilities of timber in tension on an anticlastic surface. So we looked at this site we took a closer look at the site. I'm sorry, and decided to zone the roof into 3 prominent spaces. The first one of them would be the bar that was that you see in the top right corner of the roof, a shaded gathering area in the center, and the vista that overlooks the most happening intersection in Poblano, and everyone here at IAAC knows why. So since we knew that we wanted to base the roof structure on an anticlastic surface, we went on to analyze the principal stress lines in these surfaces, which more often than not would lie along the UV diagonals of the surface. So we built a surface up from these principles, with a grid of catenary and anti-catenary curves, both structurally acting against the self-weight and wind uplift respectively. We also explore a wide catalog of possibilities of grids, and we chose a particular grid for its uniformity and density, but that was not all. We also went ahead to develop variations in this grid in terms of density, patterns, and shading, and found out that the first 2 iterations performed very well. Not only in terms of ease of fabrication with parameters like angles and spacing between these timber members, but also in terms of its environmental performance and its capabilities against solar radiation. Well, after all, it's a rooftop, and Barcelona, as we know, it is quite hot. This combined with painstaking efforts of optimizing this structure to make sure the TIT grid actually acts in tension, we went through a lot of analyzing back and forth with Karamba. Along with all these digital tools, what was also important was to explore these capabilities of timber in the physical world. So this is a test set up to visualize the degrees of tensile stress experienced by a single TIT member. And we also did tests to visualize the overall working principle of these kinds of tensile structures. We also tested a couple of shortlisted connections we designed for these TIT members for their breaking points to know what we were dealing with. And we also tested a single TIT member glued, screwed, and spliced with a point load equivalent to 1 Raimund Krenmueller. I'm sorry for the pronunciations. And all this brought us to the new rooftop, brought the new rooftop into being. And now I hand it over to my colleague Michelle to zoom into further details.
Okay, to touch briefly on some of the details that were critical for the design of the structure. One main challenge was how to incorporate the structure within the existing roof structural framework. And what we found during our research is that below the roof was actually an empty space, which meant that the columns could not be supported on the roof itself. So we supported them on the parapet walls. And to do this, we used an angle, bracket, and bolt connection. During the assembly, we attached the prefabricated column and angle brackets to the threaded rods, which were embedded into the parapet wall. During the structural tests, we saw that the tension on either side of the beam created axial stress on the column. So the design of the portal frame uses layers of plywood and wood to prevent rotation and deformation. The openings in the beam were calculated and incorporated during pre-assembly for the cables to pass through. For the cable connections, we focused on balancing the tensile load on either side of the main beam. The spacers were prefabricated, and this made for ease of assembly on site. The connection of the timber and tension to the beam followed a similar design to the cable connections, only this time the end of the cable is attached to a threaded rod and steel tube. The timber and tension is layered between 2 plates of plywood, which takes advantage of the shear connection between the plates. The plywood plates were CNC'd to fabricate the custom angles required for the design, and using the threaded rod and cable connection allowed for rotation and movement during assembly. The connections were fastened to the main beam while the tensile timber was lifted into place. The splice plates were designed to allow for the timber to bend continuously without breaking where the timber is spliced. As we saw in the structural test, the dowel performed the best with the shear loads, so we used this concept and altered the sizing for the final design. At the edge beam, we use a similar concept as the splice plates, but use 20mm steel tube as the dowels with washers to cap and hold the wood into place. And we designed some furniture elements that would make efficient use of the material we had and be able to incorporate weight at the base. Vertical timber and tension columns were implemented to transfer the wind loads from the tensile roof down to the furniture and to prevent lifting. And this is the props we used as we were lifting the timber and tension into place. And the props actually allowed for us to build the curved form into the tensile roof. And finally, Raimund for another structural test. And that's it. Thank you.
Thank you very much. So now we would have the cover popping on the rooftop, ideally. But if the speakers still have a little bit of time to stay with us. There were some questions from the online audience that I would like to put to you. So one that is kind of a bit kind of questioning the savior image that we discussed before, like from PA8. I live on Vancouver Island, BC. The timber industry is devastating our old growth forest and by large clear cutting, changing the natural environment. Snow melts faster in open clear cut areas, removing natural chemistry from the forest floor. Oh, I see that Tom Westwood actually responded to that, and I think Tom had to leave already, right? Any replies to that? Let's say, what is actually the, how good is timber really? Does it have like a, does it have this image without it deserving it, or what else has to be done right, like forestry, like sustainable forestry, to actually maintain these benefits of timber? Any comments?
Timber's a bit like diesel was. Like diesel was really good for carbon, so everybody was promoting diesel, and then there were diesel cars everywhere, and now we're all dying of pollution. Do you think timber might be a bit, the unmitigated use of timber might be a bit like that? It's a great carbon solution in the short term, but it's not a great solution environmentally across other, on a broader spectrum. And particularly CLT uses very large volumes of timber compared to the volumes that are necessary for structural design. So it's kind of giving people the feeling of making a concrete building that looks like timber, but actually it's not very efficient. So I share the concerns of PA8 that we should be careful with timber use as well.
Yeah, and as Tom put in his reply, that yes, like if the forestry is really like in well, in this kind of privileged areas like we have in Austria, where really the timber that is extracted is kind of carefully selected. This is maybe, is a little bit like ecological agriculture. Like it's great if it's possible, but it doesn't scale indefinitely. So this kind of forestry perhaps is the right way to do it, but also it's just not possible everywhere, and there is limits to, let's say, to the benefits that conventional timber use provides. Any other questions or questions from the speakers to the students? Oh, there is one here. Whoop.
So I'm from a place where there isn't many trees and a lot of sand and a lot of heat. How would timber work in these situations? Like, how do you make it durable in places like that?
So in climates where there is no wood or relatively little, how to popularize timber? Maybe not. Maybe don't do it. Or ship it there from Canada or from Finland. I don't know. Any response to that? So obviously timber is not the solution for everywhere. But
well, I can have a comment if you want.
Yes, please, Kasper.
So actually what we're seeing right now in the industry is, especially through Corona, is the prices within timber and wood in general are skyrocketing. So we've been building some smaller projects through the Corona period here in Denmark and in Sweden. And prices have gone up 30% in the past year and a half. And that's got to do with the fact that sourcing back and forth across the Atlantic, right? So this is exactly what we're talking about. We usually, like in Denmark, for example, we don't have any wood. All of our wood comes from Sweden. One of the other issues that we also have is that the timber industry is just simply not mature enough. We don't have the appropriate engineers. We don't have the appropriate contractors to carry out, and it costs tons of money to source the wood from abroad. So I would definitely have some kind of reservations towards just, you know, throwing it all in there and say timber is the best wherever you build. But also there's the whole pricing at the moment, right? It's really skyrocketing. So we can try and promote building in wood as much as we want, but right now it's really difficult to actually, we're talking on a sort of from a commercial perspective, to hit price range actually. Sorry for being boring.
That's fine. We like the party poopers.
But maybe to kind of comment to that, because it's also about, you know, like actually revealing much more what is happening behind the scenes, right? And that kind of accounts for everything. It is like really, I mean, it's very difficult to understand all the parameters that are involved in all the projects, the carbon calculations and whatever has been actually part of the design process, and also kind of considerations. But I think actually we can try also in the industry, or we should actually be much more clear. I saw one comment about certification, but also actually just acknowledging what we have done, which decisions that we have made, if they are on hindsight good. How can we evaluate over certain lengths of time? And actually, I think also there lies a really a responsibility from us to be more open and to say, well, actually, you know, these are reasons that you know, have deliberately driven the project in a certain direction, and or you know, like material choices or collaborations, etc. Yeah.
Thanks, Manja. I actually had a question prepared for you because I remember, like, at the end of the Nepal project, you said like next time no timber. So
I don't remember that.
We ended up doing it again. I was wondering, like, why is timber for an engineer, like, what is painful about it? You know, it's all great and sustainable, but also you know, detailing with it can be annoying. Maybe I see Kasper indicating he also has something to say about it, but maybe Manja.
No, it's just because I already know Manja's answer.
Oh.
Go ahead, Manja. Go ahead, Manja.
What is it going to be? No,
the connection. Making the right connection.
Connections are really difficult, and also what some of the speakers already said before, actually, you know, touching on fire, or how you actually, you know, get a more like hybrid system through kind of approvals. Yeah, that's just, it is very or it can be really painstakingly difficult. And also end up in just a no from some people to say, okay, actually, so in the end, we are just, you know, going for this kind of simpler option. And obviously, I think it's really good to take challenges. And also, it's really great to learn and to think about alternatives. And yeah, connections indeed are very difficult. Also, I think we all turned out as Popeye from kind of carrying hardwood, which was the locally sourced kind of material that we had there available in Nepal. Also, maybe have made me given this kind of comment at the end. But I think it's important to again, like similar to what I mentioned before, to actually talk behind the scenes, and something also what the students just said, it looks really simple, but actually, you know, there goes so much work into, you know, devising the right kind of connections or construction strategies. And yeah, so I think that's it. But I like Kasper, that also because obviously we have been on kind of this complicated timber construction projects, commercial projects as well together. Yeah, it takes time. Almost in my presentation, I was going to put some of the earlier kind of Zaha works where, you know, you have all the kind of curved glass kind of panels. I also think like some things just need to be hard in the beginning, but we need to put them into the world to actually for others and to discuss them, and so that they can, yeah, kind of really grow into kind of evolving and become smarter, because more people have the ability to see them and, you know, to build on, yeah, build on this knowledge.
Yeah, I remember when in the midterm of data informed structures, we actually had Jean-Nicolas and Zachary from Hook Park joining and showing us also the sawmill shelter project. And the question came up, like, why, if timber is also great intention, and why nobody is doing it? And the answer was, yeah, because it's so goddamn difficult. Because to actually put all this tension in this material allows for a very sophisticated detailing, and it's just it's not so easy to, let's say, yeah, to make a project to actually use this capacity in a smart way easily. So so yes. Any other questions from the audience or from the speakers or from you guys?
I have a comment.
Yeah, and did I see Martin raise his hand as well? Nope. Kasper.
Yeah, no, I just I just wanted to congratulate the students on the work. Really amazing, because I saw the first take where I think you had 5 or 6 proposals. Which one are we going to go for? And we discussed them at the time for the midterm or whenever it was intermediate crit. So really elegant project that you guys have pulled off. The details are beautiful. I absolutely love them, and I must admit it must have been great just to, you know, you see the whole process, the connection between the big picture and the small detail, and everything, all the steps in between working together is really must be satisfying. So I just wanted to congratulate you and tell you that I think it looks really cool. And the only question I had was for the assembly, because I didn't really see that in the presentation. Remember, I think I did a short presentation to you guys about assembly strategies, and I would have been interested in seeing a little bit more about the let's say the process of, because the whole woven sort of structure on the ground goes up as if it's a carpet and then gets hooked to the portal frames. And it looked as if that actually happened very elegantly and sort of was all thought out. I would have been interested in hearing more about, but maybe I'm wrong. I would have been interested in hearing more about whether that was a specific sort of process sequence, something like that.
Anyone wants to comment? So the reason why it looked so elegant was because it was the second time we did it. So the photographer, luckily for us, showed up on the day we lifted the other side of the carpet, if you like, and there we already knew all the things that will go wrong from the previous day. So the way it was done, actually, it's not really in the two directions of the timber elements are not really interwoven. They're just kind of two pretty independent layers. So they were laid out on the rooftop, and then we had like an intermediate kind of edge beam that we later removed, which we used to connect with the ratchet belts. And then we pulled it up, temporarily fixed it. And while it was fixed, kind of closed the structural connections. But yeah, the first time it really was not as smooth. No?
Well, it was nice because it was, at least the way you presented it, it reminded me almost of, you know, the story about the Frei Otto Multihalle, where which is this entire layered wooden grid shell that is woven together on the ground, and then it's sort of pushed from the sides until it creates a bubble, which is an amazing way of assembling a structure, right? Or erecting a structure. It just reminded me of that process. It's really interesting.
Well, that's good company, let's say. I see here in the chat that Teresa also is about to leave, and she says congratulations for the project and looking forward to visiting it for real. Yes, definitely. Also, I think we should in the future try to nourish this kind of exchange that we have here between kind of London schools, practitioners, the EPFL, and here IAAC in Barcelona. And I'm looking forward to seeing you for the next roundtable. I don't know yet the name, but we only kind of, let's say, we scratched the surface on many things today, but and certainly we have discovered, let's say, a lot of questions, if maybe not have found all the answers, obviously. And there is a lot of topics that are hot and that will kind of stay relevant for the years to come. So with that, I would like to first of all thank the speakers for coming: Kasper, Ax, Martin Self, Steve Webb, Manja van der Worp, Tom Westwood, and Teresa Cheung. Thank you so much for your presentations and for joining us here today and participating in the discussion. Thank you guys for coming here physically. It's so much better to have some actual faces in front of you. No offense to the online audience. And also shout out to people here at IAAC: Gabriele Jureviciute, Daniela Figueroa, Matilde Marengo, Alex Dubor, Pilar Chicas, Xavier Molons, and the entire communications team of IAAC, putting together this event and video and all the social media posts, etc., that goes along with it. So, well, obviously you guys for pulling off this work, and especially Michelle and Laukik to prepare this presentation. So thanks again. I think this thing was recorded, as far as I know, so it should be possible to somehow look at it again. And yeah, like I said, many points raised and nothing concluded, which leaves us for, you know, with a lot of things to talk about and discuss and experiment with in the future. So that's it from here in Barcelona. And thanks again for coming. And I hope to see you all very soon in real life. Thank you. And good
Thanks,
night.
Raimund.
Thanks.
Amazing job.
Congratulations. Bye.